So now the next one is solid angle. Okay. Next one is solid angle. In solid angle, we write what is that? Solid angle is d omega, right? D.
Sir.
So suppose like you are taking a sphere. You are taking a sphere. Sphere means like a watermelon. Think like a watermelon. You see in India, what they do is if you want to check whether it is red or not, or whether it is having water or not, in that what we poke in the watermelon. We poke in the watermelon like with the knife. We make like a triangle thing. One, then second, then third, and we pull out the piece out of it. Is it not? So that is a 3-dimension thing, not a 2-dimension thing. So now we have. So here we have this is what dA, okay, and this is d omega. This is r, okay. So what is the formula here? D omega equal to dA by r square.
R square.
Okay, unit of this is what? Steradian, SR. Steradian. We write SR, okay? Steradian or SR. So this is the formula, okay? Now, so copy this, then we'll go ahead. You got the idea? This is so this was the first part of the lesson. The second part is about the significant figures. Okay, there are rules for significant figures. What are they? We'll just quickly discuss that. Okay. Yeah. There are seven rules while writing the significant figures. Before that, we have here one more thing. So we should know how to convert degrees to radians and radians to degrees. Okay. So just I will degrees conversion. Okay. So conversion process. So yes, I think. Is it T or S?
Yes, sir.
Yes. Yes. Okay.
Yes, sir.
Okay. Conversion. So here the first one. We have degrees to radians. Degree to radian. And radian to radian. So suppose if it is 60 degree, how will we convert? You have to multiply pi by 180 into 60. So that will become 3. Answer is pi by 3. Okay. Answer is pi by 3. Okay. So next you know what? Degree radian to degree. Second one is radian to degree. Radian is how much? Like if it is pi by 4, multiply 180 by pi like this. So this and this will go over 45 degrees. This is the way you convert degrees to radians and radian to degree. Okay. And also we should know few values. What is that? Milli. Milli means how much? 10 to the power of, which is written as m. 10 to the power of minus 3. Micro means mu. 10 to the power of minus 6. Nano means n. 10 to the power of minus 9. Okay. And then we have pico. P 10 to the power of minus 2. Then Fermi. F 10 to the power of minus 15. Then we have 10 Then we have kilo here. Kilo means 10 to the power of 3. Mega and 10 to the power of 6. Giga G 10 to the power of 9. Tera T 10 to the power of 12. Okay, so these are the values, standard values. You need to remember the symbols. So they are, just remember the symbols now. After that, we have 1 atmospheric pressure, decimeter cube, and one more thing. I just would like to tell you, 1 ml. Keep this in the mind. 1 ml is equal to 1 cubic centimeter. That is 1 cc. Okay, 1 cubic centimeter. 1 ml is equal to 1 cubic centimeter. Next one is what? We have 1 decimeter cube. 10 to the power of minus 3 meter cube. 1 decimeter cube. 10 to the power of minus 3 centimeter cube. This is used in chemistry. Decimeter cube. Liters instead of liters, they give in terms of that value. Okay. Is it clear?
Yes, sir.
Yes, sir.
Let's copy this, then we'll go ahead. We'll discuss about significant figures. Okay. So significant figures. The first point is what? All the non-zero digits are significant. Okay. There are total 7 points. All the non-zero digits are significant. Example, I write the first point is 2308. Okay, 2308. They're all significant. So if you ask me what is the significant figure of this, it is 4. A number. Okay, the second one. All the zeros between two non-zero digits. Okay, 2358, right? 48. Now 2308. Again, the zero between any non-digit is also a significant. No matter where the decimal point it is. If the number is less than 1, the zero on the right of the decimal point, but to the left, are not significant. Example, 0.002308 is given like this. It is less than 1. There is a point here. These two zeros are not significant. These two zeros are not significant. So what is the significant figure? It is 4 again. Why? Because we can write again in the standard form. If you are not able to express that, 2.308 into 10 to the power of 1, 2, 3, 10 to the power of minus 3. So we have 4 significant figures. Is that clear? Fourth one. The terminal or trailing zeros in a number without a decimal point are not significant. If it is 1, 2, 3 meters, can also be expressed in 1, 2, 3, 0, 0 centimeters. Can also be expressed in 1, 2, 3, 0, 0, 0, 0, 0, 0, or 1 more millimeters. Okay. So whether it is, so whatever it is, so here in a without a decimal point or not, why not significant? This also can be expressed as 1, 2, 3 into 10 to the power of 2 centimeters. This also can be expressed in 1, 2, 3, 10 to the power of 3 millimeters. So here the significant figures are how many? Only 3. These are the 3 significant figures. Is that clear?
Yes, sir.
Yeah. Next one. Next one. If the trailing zeros in a number with a decimal point are significant. Like suppose if you are writing fifth one, 3.3.500. So the significant figures is 4 here. I'm writing 0.06900. This is not significant, but these are significant. So the significant figures are 4. Because you have to consider all this. You have to consider this. These zeros are not significant. Zero for a non-zero decimal is significant, is not significant. So best way of if you are not able to express it properly, the best way is what? Just write in the standard form. If it is like 4.61, if it is 4.700 meters is given, we are not able to find out. You are not able to understand whether it is how many significant figures. Just write after point to be considered, right? After point it is to be considered. Is it not?
4.
Yeah, it is 4. So that is the way you write. Okay. So the significant figures are how many here? 4. Okay. So please copy this, then we'll go ahead. Write the points also. Write those points also. Rules for arithmetic operations, whether it is multiplication or division. How to do it? Let us check. Now, so we have density. So density is what? Mass by volume. Okay. Density equal to what? Mass divided by volume. So it is equal to what? 4.237 divided by 2. This is grams divided by 2.51 centimeter. Keep this in the mind. Okay, when it comes to density part, I'll just write here. Density is what? In SI unit, it is density is measured in kg per meter cube, or we can write gram per cubic centimeter. So we write here 1 gram per cubic centimeter equal to 1000 kg per meter cube. This is a special case where CGS unit is greater than MGS unit. We have CGS unit. Okay. So we have a system of units. In system of units, we have 3. What are they? CGS, NKS, which is also known as SI, Standard International, FPS. This is centimeter, gram, second, meter, kilogram, and second, foot, pound, and second. Okay. So centimeter, gram, second, meter, kilogram, second, and foot, pound, second. Okay. So that is here, when we write here, there are 4 significant figures and there are 3 significant figures. So when we write the answer should be in the form of 3 significant figures, the lowest one, the least one. Okay. It should be of least significant figures. Right? Is it clear? So this is the special case where CGS unit is more than the SI unit. And this should be in the, if it is 4 significant, 4 and 3. So you have to write the answer in terms of the least one, 3. Now we'll go with addition and subtraction. Second.
Sir?
Yeah, yes, please.
So 1 minute, sir. Below that paragraph, right? Like the density thing is given. Below that, it's given like the speed of light is 3 × 10⁸ meter per second in the
Yes.
text.
Yes.
Yeah, and then 1 year is 365.25. The
Yes.
thing is given, right?
Yeah.
So the final answer should be in 1 significant figures, right? Because the least is 1. But there in the answer, it is given 3 significant figures.
Where? In the, okay. 3 × 10⁴ okay. So what is it if the speed of the light is, okay, 3 significant figures and 1 light year is also given to you, has this much. So 1 light year is how much? A distance traveled by light in 1 year. So it should be 3 significant figures. No, yeah, 3.00. It has, when we are writing 3.00, it has 3 significant figures. If you are mentioning like this, if you are mentioning like speed is equal to velocity, that is 3.000. That means what? 3 significant figures. It is 3 significant figures. Even though after there are zeros after the point, that is to be considered, right?
Yes, sir.
If it is not, if he is only writing 3, then it's okay. Got it?
Sir, but it's written only 3.
It is written, see, Yeah,
No,
I
it
do
is
understand. If it is only 3, it is one significant figure. If it is only 3 into 10 to the power of 8, we are writing. Actually, it is why we have written like this. I will tell you. Actually, it should be like 0. How many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8. That many zeros are there. Got it? So instead of writing that, what did we write? We wrote here 3.00 into 10 to the power of 8. So according to the rule, if you go to the rule, so after the points, if it is before the non-zero decimal, then it should not be considered. If it is zeros after the point, it should be considered, right?
Yes, sir.
As per the rule, we are going as per the rule. So we are writing, that is why computer, especially when we are doing the in banking problems, in banking numericals, or in any other way, whenever we are doing, they have 2 significant figures, 3 significant figures, 4. Like if you check the currency, 1 dirham is equal to how many rupees? It will show, I don't know, 0.00 something, 413 something, I don't know how much it is showing. If you take only 2 significant figures, it will become only 0.00 only. Is it not? Got it? So we have
Yes,
we go to 0.0041 something. So the currency is calculated in that way, maybe up to 4 significant figures. Got it?
okay, sir.
Is that clear? Suppose
Yes,
if
sir,
you
it
say
is.
only 22. Now suppose I say 1 dirham is equal to 22 point, like example 542 rupees. Here there are 4 significant figures. Now if I say only 2 significant figures, it will become 22 rupees, is it not? Then what do you say? No, you are giving me less amount, is it not?
Yes, sir.
When I give more precise, especially if you go to currency exchange, 22 point, he will give 425. You will be very happy, is it not? We are getting more money. Got it? So that is why they go up to, maybe sometimes they go up to 6 significant figures, something like that. Got it? So that plays an important role. And then here one time is also given here. 365 days equal to also given. That is in 5 significant figures. But the answer is only in terms of. So I'll write that also. 1 year. So 1 year equal to 365.25 days. So that will be equal to how many seconds? How much he has given there? 9.4, sorry, 3.15, 3.1557 into 10 to the power of
7.
7 seconds.
Sir, the speed of light in vacuum is 3 into 10 raised to 8 meter per second, right, sir?
Yeah, this is 1 year, right?
Okay, sir.
Time, that is time. 1 year equal to that many days. Seconds. So 9.47. So when speed is equal to what? Distance by time? We have to calculate the distance. 1 light year is a distance, not the time. So that is, if we multiply, the answer should be from 9.47 into 10 to the power of how much? 10 to the power of 5 what? 10 to the power of 15. Okay, 15. Yeah. This is about 1 light year. Got it? Now, the second part is about addition and subtraction. Is it clear? Is this
Yes,
clear?
sir.
Okay. Can I raise this part?
Yes, sir.
Yes, sir.
Okay. Next one is, here we have addition or second one is addition or subtraction. Addition or subtraction. So how much it is? 0.7 meters minus 0.304. That is equal to how much? 0.003 meters, which is 3 into 10 to the power of minus 3 meters. Okay. So this is about the addition or subtraction. So when we subtract or add, it should be in the same significant figures. Okay, and the answer also should be in the same significant figures. Okay. So the last part will be decimal dimensional formulas. So dimensional formulas we'll see tomorrow. Okay.
There is determining the
So
uncertainty
addition
also, right?
Addition or subtraction, whenever we do that, both should be in the same significant figures. If it is not there also, example, if one is in 3 significant figures and one is in 2 significant figures, add one more 0 to the end. If it is like only 3 0, make one more 0, right? One more 0, then solve it. Okay. Is it clear?
Yes, sir.
Sir, there is also determining the uncertainty in the results of arithmetic calculations, right?
No, I didn't get it. Can you say it again, please?
Rules for determining the uncertainty in the results of arithmetic calculations. So we'll do that after dimension analysis.
Yeah, uncertainty in the measurement, right? That is 0.5 and all. Okay, tomorrow we will see.
Yes. Okay.
So is
Okay,
it
sir.
okay 9 o'clock or 9:30? What time is okay with you?
9 o'clock is fine, sir.
9 o'clock is fine. Okay.
Yes, sir.
Okay. Anyways, the recording I will put it on the channel, and you can tell Alisa and other girls also to join. I will tell the boys also. Okay.
Okay, sir.
Okay.
Okay, sir.
Thank you so much.
Thank you, sir.
Yeah.
Thank you, sir.